Hello friends, in this video we will discuss two very important questions or queries about two compounds. First is carbon tetrachloride, second one is silicon tetrachloride. Carbon and silicon are the first and second members of the same family. They show similar behavior because of their same outermost electronic configuration, but their chlorides are entirely different as far as their action with water is concerned. So CCl4, carbon tetrachloride, is a liquid. Similarly, silicon tetrachloride is also a liquid. Both these compounds are liquids at NTP. This is highly stable compound as compared to this one. Carbon tetrachloride is highly stable. It does not react with water, but it does react with water as soon as it comes in contact with even the water moisture. So why CCl4 does not react with water but silicon tetrachloride does? We have to explain. So due to following reasons this happen. What? First, the absence of d orbitals. In carbon, what we have? 1s2, 2s2, 2p, x1, 2p, y1. This is the electronic configuration, and in second cell there are no d orbitals. So absence of d orbitals in carbon. This is the first reason. But in silicon, what we have? We have d orbitals. So what is the electronic configuration of silicon is 1s2, 2s2, 2p6, 3s2 and 3p2, right? Several assemblies. So this silicon has third cell, and third cell has d orbitals. So first reason is there are no d orbitals in carbon and hence it cannot react with water. ये पहला reason है. This is the first reason. In silicon there are d orbitals in the third cell, so it can react with water. Number two reason is the rule of maximum covalency. Covalency. Carbon cannot expand its valency beyond 4. In every compound of carbon, it shows only 4 valency. It cannot expand the valency beyond 4. But in case of silicon, valency is 4, but it can expand valency from 4 to 6. Okay, please. सिलिकॉन क्या कर सकता है कि अपनी वैलेंसी को 4 से बढ़ाकर 6 कर सकता है. This is the second cause of the problem we are discussing. Because of maximum covalency rule. So what we are saying, CCl4 comes in contact with water, there is no reaction, even it does not mix. But in case of SiCl4, it reacts with water, 2H2O, forming what? SiO2 plus 4HCl. This is the end product, SiO2. And third reason is steric effect. steric effect. So carbon is very small atom as compared to silicon. So these Cl atoms are very close to it, carbon. Okay, please, like this. It is a tetrahedral structure. Tetrahedral structure. H2O. Okay, please, let's show like this. Cl here. So because of small size, electron clouds of Cl atoms, 4 Cl atoms are very close, and this H2O, well, like this, cannot approach the carbon atom. So this nucleophile, that is, electrons of O cannot approach this center of what? Attack by this nucleophile, that is H2O, because of the steric factor. But in case of silicon, it is possible. H2O, so this can attack easily. Because of the very large size of silicon, there is enough space for H2O molecule to approach silicon atom present in the silicon tetrachloride molecule. Here again, the second reason is this carbon carries very small positive charge as compared to silicon. यहाँ पर कार्बन और क्लोरीन में जो डिफरेंस है, इलेक्ट्रॉन एक्टिविटी का बहुत ही कम है, इसलिए यहाँ पर जो पॉजिटिव चार्ज है बहुत ही कम है, यहाँ पर ये बहुत ज्यादा है. कितना है देखिए प्लीज, कार्बन दिस इज 2.53, बहुत ही कम डिफरेंस है. यहाँ पर क्या है 1.93, बहुत ज्यादा डिफरेंस है इलेक्ट्रॉन एक्टिविटीज का. सो यहाँ पर क्या है, जो वाटर का ओ हमारे पास यहाँ पर इलेक्ट्रॉन है, ये जो का वाटर एक्ट्स एज व्हाट, न्यूक्लियोफाइल, न्यूक्लियस पर अटैक करता है, पॉजिटिव चार्ज पर अटैक करता है यहाँ पर. तो यहाँ पर अटैक जल्दी होगा बिकॉज ऑफ 2 रीजंस. यहाँ पर क्या है, स्टेरिक फैक्टर है, दूसरा पॉजिटिव चार्ज कम है. यहाँ पर क्या है, कोई स्टेरिक हिंड्रेंस नहीं है और पॉजिटिव चार्ज भी ज्यादा है. So in this way we can explain the non-reactivity of CCl4 with water and the action or quick reaction of water with silicon tetrachloride. Second question regarding these two compounds. You see here please, the bond length here in C, carbon and chlorine, is very small as compared to the bond length between silicon and chlorine. Means this bond is quite bigger as compared to this one, but the bond energy is almost equal, 330 kilojoule mole inverse, 339 kilojoule mole inverse. In general, what happens as we go down, because of increasing the bond length or the size of the central atom, there is an increase in bond length and decrease in bond energy. But here the bond energy is almost equal. Why? This question is also very, very important. Okay, in these two compounds, okay, there is a very large difference in these two bond lengths, but bond energy is almost equal. It is because of more ionic character of the silicon chlorine bond. तो यहाँ पर प्लीज देखिए, इन दोनों की इलेक्ट्रॉन एक्टिविटी में डिफरेंस ज्यादा होने से यहाँ पर ये जो बॉन्ड है सिलिकॉन क्लोरीन का, इसका आयनिक कैरेक्टर बहुत ज्यादा है इस बॉन्ड से, और आयनिक कैरेक्टर होने से इसकी बॉन्ड एनर्जी बढ़ जाती है. बॉन्ड लेंथ बढ़ने से जितना बॉन्ड एनर्जी में डिक्रीज आएगा, कार्बन से सिलिकॉन तक जाने में आयनिक फैक्टर के बढ़ने से बॉन्ड का आयनिक फैक्टर जो बढ़ जाता है उसके बढ़ने से उतना ही बॉन्ड एनर्जी या उतना ही बॉन्ड स्ट्रॉन्ग हुआ और बॉन्ड एनर्जी बढ़ जाएगी। इसीलिए दोनों की बॉन्ड एनर्जी लगभग बराबर है। दिस इज वेरी वेरी इंपॉर्टेंट क्वेश्चन एंड these two questions regarding these two compounds are mostly asked in various competitive exams we face in chemistry. Okay, please, thanks. Namaskar.